Good morning. Today's episode we're going to discuss about the charging system, and it's a short episode which is going to take around 15 to 20 minutes. And just as indicated on the board, the charging system is the alternator, and it has the components, the construction, and operation. Just before I go to the components, I want to give you, from what you're seeing on the projection, I'm telling you talk about what's the definition, what's the charging system? The charging system produces what you call AC. AC is alternating current, but must produce direct current at its output terminals. So we have AC and DC. It can be used to charge the battery and run the electronic circuits. These are things like the headlights, that's the ignition switch, the side lights, the indicators, the wipers, and all the motors. So to summarize something about the charging system, I can say that it supplies current demands made by all loads. That's one. I'm trying to summarize what it's all about, the charging system. Number two, it supplies whatever charge current that the battery demands. You know, it will be very bad that you're on the highway and then you're driving on a jam. Your vehicle doesn't have battery charge, and then you want to start your car, then you're in a mess. So you really need the alternator to charge the battery. Number three, you need the following conditions: operating at idle speed. It needs to be operating at idle speed, supplying constant voltage under all conditions, have an efficient power to weight ratio, be reliable, wired, and have resistant to contamination. That's low maintenance. It should be something that's easy to maintain, provide an indication of correct operation, and such like. Next, after that, you need to identify the components. That's what we call the various parts of the charging system as indicated on the board here. We have what we call the end cover, we have the front cover, we have the pulley, we have the armature, the brushes, the commutator, the fans, the fans, and then we have the diode, and then also we have what we call the rectifier. That's the connections. The rectifier is the one that changes the AC to DC. So we're going to see in detail how it works. So from the projection we have over there, we have many more others. Instead, like the battery, the voltage of 4 volts, there's the battery, there's the charging indicator on the dashboard or on the instrumental panel of the car, the pulley, the rotor and the drive and assembly, the bearing cover, and then the dust cap. We have the bearing cover, so here and then also we have what we call the rectifier end frame, the rubber insulation, the seal plate, the brush holder and cover, the plate terminal insulator, and rear cover. You know, these are 20 parts. A few. You can remember just a few, like 6, 10 to 10. Then you're good to go. You don't need a lot of parts, because some of them are not really major parts. So you can be asking an exam, what is the construction and operation of the charging system? Construction is just like you're saying something is made of this, looks like this is the size, the materials and everything. Then we talk about the operation is how does it work? And the simplest way to do it is just what I've just said. You just name all the components, list all the components down. For the components, you just start describing them. What is their function? And you'll get done. So from the projection we have, you can have a look at that. We are going to basically talk about the construction and operation of the charging system, whereby we are describing the alternator itself. So an alternator has two main parts, as you can see up there. So these main parts are what we call the electromagnetic rotor. Okay? Which I was trying to call the armature, but now we can call it the electric rotor, which we call it the armature of the starting system. And then the rotor now usually turned by the crankshaft driven pulley, which turns that have the crankshaft speed, and revolves inside the starter windings where the alternating current is produced. So this alternating current that we're talking about here is unsuitable for charging the battery and has therefore to be charged to direct current, changed to direct current, from AC to direct current. And what does this? What does this is what we call the diodes. The diodes. Diodes are, just for the simple, this is how the simple is. This is an electrical component that can only pass only one direction. From this one to its AC, to this side, this side you call DC. So this is the only thing that changes the current from AC to DC. So this process is called rectification. Rectification, just rectify. Something is not good, you are trying to rectify it so that it can be proper. So that's rectification. And it involves the use of a device which will pass current only one direction, which is called a diode. And in modern semiconductor rectifiers has 6 silicon diodes used, whereby 3 of them are men and 3 of them are female. So, or you can use this one, 3 of them are positive, 3 of them are negative. So the cutout is not required because these same diodes prevent the battery from discharging to the stator windings when the alternator is at rest or when the generating less than the battery voltage. So further important feature for you to know of this alternator is that it's inherent self-regulation regardless of the current output. This self-regulation is characterized by what we call a regulator. That's why we have some the alternators we have nowadays. They are called alternator regulators, simply because the regulator is put together with the alternator. But the regulator is put together with the rectifier. But the old type of alternators we used to have the regulator separate from the rectifier. So you find there's another unit outside the alternator. But nowadays, the ones we have nowadays, they are enclosed inside. So this means that the regulator has to control only the voltage which is achieved by regulating the alternator field current and therefore output voltage. So we go into the principle of operation, whereby you will basically say this. This will give you around 10 marks. The basic principles of operation of any means of production of an electric current apply. Terms and conditions apply. Simply, this begins from the fact that if a conductor is moved through a magnetic field and the electric current is induced into that conductor, then the amount of current that is induced to this conductor depends on some of the following things. This is called, in fact, these are definitions for those of us who learned this in high school in physics. It's what is called the Faraday's law. Okay? You remember about the Faraday's law, about the law of the fingers. That's we talk about the current, the voltage, and resistance. Okay? So what happens is that the Faraday's law states that simply the conductor is moved through a magnetic field and an electric current, which is induced into that conductor. That's what we call the Faraday's law. Unless you did biology. So the amount of current induced into this conductor depends on the following things: 1, the number of turns; 2, the strength of the magnetic field; 3, the number of magnetic poles; and 4, the speed at which the magnet rotates. So in practice, it is normal to use 3 separate coils of wire, collapse of wire, and now cold phase windings. I'm going to show you a figure of that. So to form the conductor, which simply means that when the magnet is rotated somewhere, like a magnet is rotating, and here we have a north pole and south pole, what's going to happen is that some magnetic field is going to be induced. Okay? And these 3 phases can be connected into 2 ways. By whichever system is used, then the resultant 3-phase output is going to be the same. So in other words, what am I talking about? If you check on this bold yellow here, very, very fast, what am I talking about? This one is going to be clear to you when you get to the workshop and then you do these things practically. But in other words, what I'm talking about is that the alternator circuit itself that I'm going to show you below here includes the charge warning light, which is always on the instrumental panel, on the dashboard. It is always a battery sign. You find a battery sign on the dashboard, and that is what you call positive and negative. That's what you call the charger, right? The dashboard. So on the electrical circuit, you're going to have that, which is called a warning lamp. Number two, which is used to excite the field. Number two, when the ignition switch is switched on, the small current needed to operate the warning lamp is also passes through what you call the rotor, and then through what you call the regulator to the earth, because any part of the vehicle is the earth. So this current flows passing to the rotor, winding, creating a weak magnetic field, which is sufficient to enable the charging operation to begin when the alternator starts to rotate. So naturally, this operation will not occur there as an open circuit, but because the bulb has blown, what is going to happen is that, note that unless 12 volts is going to be obtained from the lead that supplies to the inlet terminal, that is now, the alternator will not charge at that point. So when the alternator is operating, the field diode supply the field to the current to dictate the regulator what it's going to do. So the regulator is going to change that current from alternating current to direct current. So the engine speed rises from stationary. The output voltage of the field diodes also rises, and this increases the output voltage, which reduces the current through what we call a warning lamp circuit and causes the warning lamp to extinguish. That's why you find sometimes in heavy commercial vehicles that you should use diesel. You always have a warning lamp on the dashboard before you start your car, because it uses the force of compression to start. Then that light, you have to wait for it to distinguish out of the dashboard, so that the charging can happen inside the engine. So such protection is the protection of this diode breakdown of the main transistor and the regulator, which occurs if the alternator is charging, and a fault such as a poor connection will cause an output voltage suddenly increase. Can you imagine something called voltage drop? Voltage drop is the loss of current from point A to point B. What causes it is several factors. 1, the strength of the wire. 2, the thickness of the wire. 3, the condition of the wire. 4 is the things like the amount of voltage that is induced to that wire. You remember, if there is too much voltage and the wire is too small, you just be able to cut. And so many more. So to avoid the damage of these electrical components, or what we call surge protection, diodes is sometimes fitted between what we call the inlet lead and the earth. Okay? So the special diode referred to as the Zener diode only conducts current when the surge voltage exceeds the given value. So you know those are measures. Construction of the alternator. How is it constructed? The components. What are they made of? How do they look like? The construction of the modern alternator is going to be shown below. And the engine crankshaft drives the alternator by what we call a V-belt. A V-belt is a belt that comes from that's the camshaft, then to the crankshaft. This is the pulley, okay, and this is what we call the camshaft. So this is the V-belt. That's the other name. So the V-belt can be enclosed or it can be just outside. So if it's enclosed, it's called a chain. They give it a name called a timing chain. But if it's exposed, it's called a V-belt or a timing belt. So that's what we talk about the V-belt. So an alternator can therefore produce a high output voltage even when the engine speed is comparatively low. Alternators require very good drive belt tension to prevent the slip when the large current is being produced. That is high alternator voltage or load. So the alternator can operate at speeds of around 15,000 rotations per minute (RPM). So to finish on this, in view of these operating conditions, ball bearings are used to support the rotor. Cooling the air is also circulated through the alternator component by what we call a cooling fan, which is one of the components we have stated. And it's fixed on the rotor shaft just on the outside part. So you'll be able to find this diagram on your manuals, charts, Google search, and such like things. But for today, I think that is the end of